Hello, fellow chemists. And in this video, we're going to take a look at converting between the English and the metric system using dimensional analysis via the factor label method. This is labeled as an intermediate video because it does assume that you have some background understanding of the factor label method. And it also assumes that you have some background understanding of converting within the metric system and converting within the English system. So if you need a brush up on any of those topics, I'll put a link in the upper right corner so that you can review them. So let's get started. Up on the chart right now, or up on the screen right now, I have a chart that shows conversion factors between the English and the metric system. I have one conversion factor for length, we have one conversion factor for mass, and we have one conversion factor for volume. So as long as you know one way to get back and forth between the English and metric system in length, mass, and volume, you can basically solve any conversion problem that you're given. So let's see how we can use these conversions to solve some problems. Now what I have up here on the screen now is I've shrunken down the English to metric conversions um, so that you can still see them. But then I also have up here the English to English conversions, in case you don't remember those. And then also at the bottom of the screen there, I have the metric to metric conversions. Most professors on an exam, they don't require you to memorize all of the conversion factors. They'll give you a information sheet at the back of the exam for you to look on, and then you just need to know how to use those conversion factors. But for whatever course you're in, make sure that you do find out what is expected of you to be memorized and what information you will be given on a test. So let's take a look at some problems that are converting between the English and metric systems. So let's take a look at this one here first. It says, if a stick is 42 inches long, how many centimeters long would it be? So when you're doing any problem, first thing you want to do is kind of map out where you're going and where you want to get to. So we're starting off with inches, and that's an English unit, and we want to get to centimeters. So we want to take a look. English is inches is English, centimeters is metric. So we want to look, okay, well, for the English to metric conversion, is it English in centimeters? Yep, it is right there. So this is going to be a fairly easy one-step problem. We're going to use this conversion right here to convert for length between inches and centimeters. So you're going to go from inches and in one step go right to centimeters, which is metric. And this is just going to be one step, the overall problem. So let's take a look at how we would set this up. If you have 42 inches, then we'll draw our conversion factor line. Put inches on the bottom because that's what we want to have cancel out, and put centimeters on the top because that's what we want to get to. And we see that for every 1 inch, there are 2.54 centimeters. So now the problem is set up so that inches and inches will cancel out. Then as always, we multiply across and we divide up. And if we do that, we'll take 42 times 2.54 and then divide that by 1, and we'll come up with 106.7 centimeters. And that is our final answer for this problem. So that converted a length unit, inches, into another length unit, centimeters. The inches was an English unit, and the centimeters was a metric unit. So let's take a look at another problem that's more than one step and still does require us to convert between the English and the metric system. So for the second problem here, we see that it says, if a person weighs 144 pounds, how many grams would they weigh? So let's take a look at this problem here now. So we're starting off with, again, pounds. That's an English unit. And what do we want to get to? We want to get to grams. That's a metric unit. Okay, well, let's take a look at what the English to metric mass conversion is, because these are mass units. It's pounds and kilograms. So we're starting with pounds, and we can convert directly to kilograms, but we don't want kilograms, we want to get to grams. So first thing we're going to do is get at least into the metric units by doing this conversion here, converting 2.2 pounds into kilograms. So we'll go from pounds to kilograms. So now we're at least in the metric system. And then we need to convert within the metric system. We need to go from kilograms here to the base unit of grams down here. So we'll do that conversion second. And we can see that kilograms and grams are a ratio of 1,000 to 1 with each other. So we see that once we have this mapped out here, this is going to be a two-step problem, converting pounds to kilograms and then kilograms into grams. Once you have it mapped out like we do here, it makes the whole problem fairly easy to set up and solve. So let's start off with the pounds, 144 pounds. Draw our conversion factor line here. And we're going to go from pounds into kilograms. We'll put pounds down on the bottom so it cancels out. Kilograms up on the top. And that's going to be using this conversion here, going between English and metric. And we see that there are 2.2 pounds for every 1 kilogram. So we have it set up so that pounds and pounds will cancel out. We'll then multiply across and divide up. And when we do that, we'll see that we end up with 65.5 kilograms. But that's not what we're being asked to solve for. We want to get our answer in grams. So we've done the first step here. Now we need to do our second step. So we'll take our 65.5 kilograms and we'll do a metric to metric conversion to get it into grams. So now we're going to use this table down here. So we'll put kilograms on the bottom, grams on the top. Which one is the big unit? Well, the bigger unit's the one that's further up, so that's kilograms. So that's the big one. So since it's the big bigger one unit, you put a 1 down there for it. And then the grams is the smaller unit, and we see that it's 1,000 to 1 ratio, so there's 1,000 grams for every 1 kilogram. So now our problem is set up so that kilograms and kilograms cancels out. We'll again multiply across and divide up. And when we do that, we will end up with 65,500. And the units will be grams. So now this is the second problem that we solved, and you can see that it's a two-step problem. And for most exams, professors like to give you several problems that are considered easy, maybe 1 or 2 steps long, and then they'll give you the majority of the problems will be like intermediate difficulty level, where they'll be like 3 or 4 steps long. And then usually on exams, they'll give you some hard problems that are like 5 or more steps long. So this one was 2 steps, so this is still kind of in the intermediate, easy to intermediate range. The last problem that we're going to take a look at is getting a little bit more into the intermediate, not quite the hard range, but definitely in the intermediate range, because it's going to be 3 steps long. And it's still going to be converting between the English and the metric system, but it's going to be just a little bit more complex than the first 2 problems. So let's take a look at the third problem. All right, so this third problem says, if you have 6 gallons, how many milliliters do you have? Okay, if you have 6 gallons, how many milliliters do you have? So just like the other problems, you always want to just kind of map it out first, where you're starting and where you want to get to. So we're starting with gallons. That's an English unit. And we want to get to milliliters. That's a metric unit. Okay, so let's see for volume. What is our English to metric conversion? Well, it's quarts and liters. Well, gallons isn't isn't a quart, so we can't even use that yet. So we need to do an English to English conversion to get to quarts. So that's going to be this one down here. So our first conversion that we're going to need to use is this one here. 1 gallon is equal to 4 quarts. So that'll be our first step. We'll go to quarts, and that's still in the English unit there. And now we can then use quarts to get to liters. That's our English to metric conversion. So we'll be able to use that second. So that now we're finally in the metric system. And then our third conversion will go from liters to milliliters. So we'll have our base unit down here in liters, and we need to get to milliliters. So this will be our third conversion that we need to do, and we can see that it's a 1,000 to 1 ratio between the liters and the milliliters. So this problem is going to be 1, 2, 3 steps long. Notice how before I write down any numbers or start anything, I make sure I know where I'm starting and what I want to get to. A lot of students make the mistake of just, they feel the pressure, time pressure on an exam, so they just start writing down numbers and without really knowing what they're trying to get to or how they're trying to solve the problem. Once I have all this done, solving the problem is easy. It's just following the steps that I've already outlined and figured out how to do. So let's start by going from gallons to quarts. We have 6 gallons. We'll set up our conversion factor line for the gallons. Put gallons on the bottom because we want it to cancel out, and quarts because that's what we want to end up with will be on the top. And there are 4 quarts for every 1 gallon. That's from this conversion here. So for every 1 gallon there are 4 quarts. Now it's set up so that gallons and gallons will cancel out. We'll multiply across and divide up. As you can see, it never changes what you do when you do the factor label method, which is what makes it so powerful. So that gives us 24 quarts. So that's not our final answer though, but that does get done the first step of the problem. Now we want to go from quarts to liters. So we'll take our 24 quarts, set up our conversion factor, put quarts on the bottom so it cancels out, liters on the top because that's what we want to end up with. And now we're going to be using this conversion here. 1 quart is equal to 0.946 liters. So 1 quart is equal to 0.946 liters. Now this is set up so that quarts and quarts cancel out, multiply across, and divide up. And when we take 24 times 0.946 and then divide that by 1, we get 2.27 liters. Again, we're still not done because we want to get into milliliters, but we did do the second step. Now we're ready to do our third and final step. So we have 2.27 liters. Now we'll set up our final conversion to go from liters to milliliters. And that's going to be using this conversion down here. So we'll put liters on the bottom so it cancels out, and milliliters up on the top. What is the big one here? What's the bigger unit? Liters, because it's further up. So the bigger unit is the big one, so it gets a 1. And then the smaller unit is the milli, and it's 1,000 times smaller. So we'll put 1,000 up there for the milliliters. So now this is set up so that liters and liters cancels out. We will then again multiply across and divide up. And when we do that, we find that we have 2,270 milliliters as our final answer. And that is the final answer for the problem. So we took a look at 3 English to metric conversions, one for mass, one for length, and then one for volume. One that was 1 step, one that was 2 step, and one that was 3 steps. So you can kind of see how they can progressively get more difficult. All right, well, that's going to be it for this video. In the next video, we're going to take a look at challenging or more advanced metric and English conversions, and those are going to be ones that are 4, 5, 6, or 7 steps long. So I hope you learned something in this video, and I hope to see you for the next one. Goodbye.